Okay, page 501, number 21 and 23. We're finding max R values for bounded functions. So we're supposed to find the points when theta is from 0 to 2 pi, where maximum R value occurs on the graph. So for the first one, we have the equation R equals 2 plus 3 cosine theta. And the second one is R equals 3 cosine 3 theta. Now these are two special graphs that are named, and we're going to learn about those in a little bit in this section. And they have very distinctive shapes. So for now though, we're just going to look at them in our graphing calculator. And for these two examples, I'm now going to use the Inspire. If you want to see polar graphing in the 84, you can see the previous example on number 13. But in the Inspire, the first graph, 2 plus 3 cosine theta, looks like this picture. It has an inner loop, and it's called alimocin. And we can see that our max R value is going to be, if we count along the x-axis, is going to be 5 units along the x-axis. So that's going to be our max R. And to get it to occur along the x-axis, our angle has to be multiples of 2 pi. So with that, we are going to say that for the first one, that the max R occurs is a value of 5, and it's for when theta is 2n pi, where n is an integer. Okay, now our other curve, number 23, 3 cosine 3 theta, is a rose curve, and that too has a very distinctive shape. So looking at that curve, it has petals like a rose, and we're going to learn how to determine the number of petals and its orientation on the grid later on in the section. But we can see as we count along the x-axis, the length of that is 3. And that would go for all 3 of the petals. And since we have 3 petals and the way we divide it up, we're going to have the angle between them be a multiple of 2 pi over 3. So that's how we're going to write this one. So we're going to have a max R of 3 for theta being 2n pi over 3. Now I'm not going to attempt to draw them on the paper since I have trouble with this pen getting nice, but you can do that based on what your graphing calculator shows you.